Timber is the oldest building material in the world, but we are doing a high-tech project. And so it's possible to have this really old, natural material and combining it with the most modern engineering processes and production processes.
When we came into this project, we looked at the roof and that just bewildered us, how we were actually going to do it. When WIEHAG sat down in front of us, we knew we had the right answer.
The Macallan project is a really engineering-driven project. So the architects have made a very beautiful design, but you need engineers to make this buildable.
This is a high-technology roof, so there's something actually rather nice that it's a material as old as man.
We've never really done anything to this extent or this complexity as far as a timber roof is concerned.
The roof is one of the most complex structures in the world, which perfectly reflects the beautiful rolling hills of Speyside.
When we've been erecting the steel, we've found that it's really quite lively. It moves quite a lot. It's quite a lightweight steel frame in comparison to the work it's doing. Everything's on tight tolerances, plus or minus 10 mil globally. Something we've never seen is these hydraulically controlled props that allows the structure to be manipulated to cope with tolerance.
The steelwork's absolutely unique. It was a jigsaw put together 15 metres above the ground.
The advantage of timber really comes into work when you think of wide-span buildings. More and more high-class architects are detecting the material again.
From a hand-drawn sketch, we'll begin to take that into the computer and convert this idea of a roof into a design for a roof. There's a huge amount of computer brainpower in the final working 3D model.
When we realized the geometry of this building, we decided to go for a parametric approach, which is very unusual in our business.
The parametric model is really powerful. Everything is interlinked. So if you have a curve, if you manipulate that curve, that change will ripple through the whole model.
To see the brains that work that out, when you're 200 metres away and there's load and wind and snow on there, it affects the beams here.
This roof exists of 1,800 single beams, 2,400 roof elements. Overall, it's 350,000 single parts, and none of the parts are equal or the same.
Each of these sticks is cut individually. Each of the nodes got a name. Each of the beams got a name. That beam goes in that place. That cassette goes in that place. We just can't get it wrong. It's 3 weeks to do a full pod, so we're hoping to get this complete within the next 3 or 4 days, and that'll be the first pod covered over.
The rise in the forms is an expression of each of those still houses. It's not a constant rhythm. It's 4, and then it extends higher. That's to draw attention to the point at where you enter the building.
We wanted the whole landscape of the building to be very much a manufactured landscape. Although it's emerging out of the ground, it's not intended to be lost. It's not a secretive building in that respect.
It's funny, everyone describes it as a curved roof. There's not one curve in it. It's a triangulated matrix of grids.
If you look at it directly on plan, it's a pure 3-metre grid, and it's only distorted as you look at it 3-dimensionally.
It will look man-made, but once nature has done what nature does, this should blend into the hillside almost effortlessly.
Clear to see how stunning the roof looks. Everything's growing, it looks lovely and lush and green. In May, it just started to flourish, and I just think it looks great.
It's pure Scotland. To see that with a backdrop of hills, this is just one new addition to something that's been taking place over hundreds of years.
Seeing the ceiling soar above you, almost like entering a cathedral, it's an amazing feeling.
This is for sure the most unique architectural building we have ever done. It is a building for the future.